Okay, Monostable Multivibrators. Okay, the function of the Monostable Multivibrator is to serve as a contact debouncer. Now what happens sometimes is when you press a button, what actually happens inside the button due to the elasticity of the contact is instead of a signal like that going through to the device, what actually happens is it actually bounces the two metal contacts on each other, and as a result, instead of sending through one signal, we are sending through multiple signals, which in a device could be read as multiple signals instead of the single signal. So we use it for debouncing of contacts. Because of this, these circuits are sometimes called one-shot devices, which means once they are triggered, they stay in that unstable state for the duration of the time, irrespective of what happens. So what that means is when I trigger on this first pulse, it ignores all the remaining pulses for the duration of its timing cycle. Now for the 555 monostable we see the following circuit diagram. Again, we've got our 555 IC. We've got pin 8 that connects to the positive supply. We've got pin 1 that connects to the 0 volts, the bottom, and we've got pin 3 that connects to my output voltage over there. Now in order to allow for stability and avoid any shadow voltages, we've got pin 4 connected to the positive supply, and then we've got pin 6, pin 7 connected to each other. We also have pin 2 that's going to be connected, and sometimes they connect pin 5 to a capacitor that goes down here, but in this case we're not going to focus on that. So pin 2 is my trigger input, and I'm going to connect that through a pull-up resistor, let's call that R1, and then I'm going to have my trigger switch. Okay, so this will allow a constant high voltage on pin 2 to ensure that when I trigger it, I pull that voltage down through the switch to the 0 volts, and that will then trigger my IC. My second input, pin 6, which is my threshold, is going to connect to an RC network. Okay, remember, the resistor and the capacitor will develop a time constant between them. In order for that to happen, we're going to have pin 6 connected to that point over there. That's R2 and that is C1. So that's R2 and C1. Now, as this circuit operates, we can see the following. Let's just move this up a little bit. We will have three scenarios in this. The first one is what happens on my input, so voltage on pin 2, which is my trigger. When that switch is open, we will have a constant high voltage on pin 2. Secondly, if we're looking at this network over here, when my output is 0, pin 7 will connect through the IC onto pin 1. Because it's connected, I will have a constant 0 volts on pin 6. So my voltage on pin 6 will be low. And as a result, my output voltage voltage out will also be low. Let's move this up a little bit. Okay, so now what happens is, as I quickly close that switch, we will have the following happen. My output will switch high, and because the output switches high, pin 7 disconnects from ground. That allows for this capacitor over here to start charging through that resistor. Now the rate of the charge of this capacitor depends on the size of the resistor as well as the value of the capacitor according to that formula. So now this capacitor is going to start charging, and as it charges, its voltage is going to increase, and it keeps increasing until it reaches the 2/3 of the supply voltage. 2/3 reaches the 2/3 of the supply voltage. Once it reaches that 2/3 of the supply voltage, it is going to force my output to switch back into the low state, or the 0 volt level. Because it switches back, pin 7 connects back to ground, and that causes this capacitor to discharge almost immediately, and that allows for a 0 volts on my capacitor again. The input remains high, pin 2 remains high for the duration, and it is going to now wait for the next pulse, which in turn will switch the output on. When the output switches on, my capacitor is going to charge again, and when it reaches 2/3 of the supply, that will turn the output off, which then re-triggers pin 7 so that capacitor can discharge through it, and once it's discharged, the voltage is 0, and we wait for the next pulse. 555 Monostable Multivibrator. A 741 monostable. Okay. The construction of this circuit is very similar to that of the bistable. We've got our op amp, inverting and non-inverting inputs. That is my output voltage, and again we've got a feedback network. But instead of a resistor over here, we've got a capacitor that connects to 0 volts. Call this C1, that is RF. My input on the inverting connects to a capacitor, to Vin, and we've got a capacitor connected over here to a negative reference voltage. The function of that negative reference voltage is to ensure that when there's no input over there, my negative reference voltage is connected over onto my inverting input. Now looking at the operation of the circuit, we've got the voltage on the input, which we're going to look at. We will have our voltage on the output that we're going to look at, and then we're going to have a look at the voltage that develops on my feedback resistor. Remember, when this capacitor is, before we go there we've got plus V and we've got minus V. Now we have to remember that plus V, my output, is going to be either equal to the plus V value or the minus V value. Because of this configuration and that negative reference over there, when the circuit is not triggered, I will have a low voltage on my input. That will be equal to minus V reference. Okay, my output will be that's a negative there, so I will have a high voltage, a plus V value on my output, and my capacitor would have charged through this resistor, and because there's no current flow through this resistor, we will have 0 volts on the resistor, and we will have the output voltage on the capacitor. That means we've got 0 volts over there. Now, I've got 0 volts as my reference over there. So the moment my input voltage over here increases, even momentarily, above into the positive value, what that does is it forces my output over there to go into the negative reference value. Sorry, it goes to the negative saturation value, and it'll stay there for a certain duration. Now what happens is this capacitor over here is going to cause a quick discharge, and because of that quick discharge it forces a quick positive voltage, and then it's going to charge or discharge. Sorry, it's going to start charging up through my resistor, and once it reaches the value of my positive, the value of my negative reference, this value over there is minus V reference that we obtain from my input there, because now my input has become the reference voltage. So once that happens, my capacitor resistor combination is going to force this to switch back into my positive saturation. When that happens, my capacitor is going to quickly discharge and recharge, and that's going to cause my resistor to obtain 0 volts on itself again. My input is going to remain like that, and we are going to just wait for the next pulse. Now we will see in the output that the output voltage is positive saturation, and it switches to negative saturation when I apply the pulse. If I want a negative voltage to be my stable state, then I need to supply a positive reference there, and then basically this graph and this graph and that graph is just going to flip upside down. This is called my inverting monostable multivibrator. In order for me to calculate the period at which this is going to stay, in order for me to calculate the period of time in the unstable state for the circuit, I use the formula T equals 0,693 multiplied by my feedback resistors value multiplied by the value of my capacitor over there.